Hello and welcome to this lesson on polar coordinates. In front of you there's a wall. Your task is to describe the position of the person's nose, that's the tip. We could describe that it was roughly above halfway on that painting. It's hard to really describe where it is in reference in general. If I said, well, you need to go along 5, you might ask from where? So we need to have some sort of reference point. In maths, we often use a coordinate system to specify the position of a point in either 2 or 3 dimensions. This room here could be thought of in 3 dimensions, but if we only focus on this wall here, then we may want to specify a point at which we are referring to in relation to all of the numbers that we get given in terms of measurements. And typically, we've gone for the bottom left. So this bottom left corner is going to be 0, also known as the origin. And down here, we can count a certain amount across, which we call the x-axis. And we can extend this line here to be the x-axis. And we then count however much upwards. And this is what we call y. So this works in 2 dimensions here. And if we were to consider 3-dimensional points, it would be this line coming out here, and this would be our z-axis. We would describe this in terms of x, y, and z. We'd go across to here. The coordinate system would be 3 to represent the x direction, and going up, we've got 10 up. That would represent the y, and z, well, we could say it's flat against that wall, so it hasn't moved from the wall in any sort of Z direction, which as you can see would go through the wall, and we'll say it's in line with the wall. I mean, we could argue that it's towards us, isn't it? Maybe ½ a centimeter, because maybe the canvas. So we've got this system for defining a point called the Cartesian. However, there is another system called polar coordinates, and we use that to specify the position of a point in 2 dimensions. But instead of using the x-axis and a y-axis, polar coordinates use 2 different measures. Let's say we wanted to define this point right here, and we still have our reference point, which is the origin, and instead of going across and up a certain amount, polar coordinates will use the distance from the origin, which we call r, and to specify this distance as an exact point will also be paired with an angle from a reference direction, and we call it theta. So the reference direction is here along the horizon, and the amount that we move around anti-clockwise, the degrees, is called theta. We could see that any point here could be measured in that way. We could pick this point here. This would have a different r value and also a different value for theta. So in the polar coordinate system, a point is defined by an ordered pair, which would be written something like this, instead of x and y. This can be helpful in certain situations, such as when you're working with circular or cylindrical shapes, where it is more natural to describe a point in terms of a distance and an angle rather than an x and a y value. You may be wondering what the big fuss about using polar coordinates is. And you know, this is great use for situations, as we said, that contain things that are circular. So if we wanted to, for example, measure a point on Earth, it's more natural to describe the location of the point in terms of its distance from the North Pole and the angle from the prime meridian. The prime meridian is the place on planet Earth which is known as the center point. It's an agreed longitude which we call 0, and it will go straight down the middle, goes through Africa, Great Britain, let's say it's here. And if we wanted to describe a location, it's called London here. And the London has a latitude of 51.5074 degrees, and it has a longitude of 0.1278 degrees east. A latitude of 51.5074 degrees north indicates a point that is 51.5 degrees north of the equator, which sits around about the center of Earth around here. So London is the curved amount up 51.5074 degrees from here. And interestingly, the north and south poles are described as 90 degrees. The equator is the 0 point. So if we wanted to know the distance now from the North Pole to London, we could simply do the takeaway sum to find the distance that we have, which is, and we know from the fact that London is located on a longitude of 0.1278 that it is that specific amount of degrees from the prime meridian in this direction. And so we can then write our polar coordinate of London from the North Pole as...
Uploading.
A fun fact about polar coordinates is that they were first introduced by the ancient Greeks to describe the positions of the stars in the sky. The Greeks used them to plot the positions of the stars on celestial maps, and then used these maps to predict the movements of the stars and other celestial objects. Then the points in the sky that are directly above the North Pole. Okay, so that straight up from here, we've got those points in the sky. And then they define the prime meridian as the line that passed through the North Pole and the point in the sky which is directly above the observer. We could say the observer was here for making this east. Therefore, the prime meridian is exactly straight up. And then you would measure the distance of a star from the North Pole, measured in degrees. So the star's here. So from the North Pole, we're going to look up until we're in line with it, and then we're going to move across, and the angle of the star from this prime meridian, which we just defined earlier, is going to be representing the star's azimuth. If I say we wanted to plot a position of a star in the sky, and the star was located at an altitude of 45 degrees above the horizon, and then it had an azimuth of 30 degrees, then the astronomer would represent this position as, then over time, as we said, it would be developed and used to make predictions on how they moved and find patterns.